so as I have said, this will be our working diagram now. As you can see, this is a triangle which is taken from our parallelogram earlier. Okay, as you can see, we have the two sides given, which is the 100 Newton, the 150 Newton, and there you are, our unknown, which is the F sub r. We are also given one angle, which is 115 degrees. Okay, now, based from this figure, this 100 Newton is our F sub 1, while this 150 Newton is our F sub 2. And based from this given, we are asked to solve for the magnitude of the resultant force. Like we've said, resultant force is the sum of the F sub 1 and F sub 2. But if you recall, force is a vector, so we cannot just simply add the 100 Newton and the 150 Newton. It's because there's a direction included. So we cannot just simply add it arithmetically. And also, class, if you can observe, the symbol for our magnitude of resultant force has a bar around it, which indicates that this quantity is a magnitude. It's because if we only write F sub r, okay, it will refer to the whole vector itself, or for the whole vector force, which means that quantity includes magnitude and direction. But if you put bar on or around it, it will indicate that it's only a magnitude. Now, aside from the magnitude, class, we are also asked for the direction, which will be in terms of theta, okay, or in angle. Okay, so to solve this, to solve for the magnitude first, okay, looking at the triangle, okay, so based on the triangle, what formula or what principle can we apply here? Okay, as you can see, two sides are given and one angle. What target do we have? It is the side, which is F sub r. So when that's the case, that we are trying to solve for a value of side and we are given two sides and an angle, we can apply the law of cosines. And if you recall, what's the formula of law of cosines? It's this, as you can see. Okay, so where is that C there? That A, the B, and the small letter C. Okay, let us analyze here. So from this figure, our C is this F sub r. Okay, that's our unknown. While the side A, that is F sub 1, the side B is F sub 2. Anyway, you can interchange. You can interchange F sub 1 to become B or F sub 2 to become A. Anyway, they are just the same side. Okay? There's no fixed position of A and B as well as C. You can use actually you can use the formula, which is B. B equals square root of A squared plus C squared.
Iwan mo yan, iwan mo.
As if you could recall, we have three equations for law of cosines, right? You can solve for side A, side B, side C. In this case, we just use the side C to represent F sub r. But like you said, you can use any of the three. Okay, any of the three equations. Okay, so the F sub 1, the F sub 2. Take note, what will be our angle here? Okay, so substituting, class, since our F sub 1 is 100, okay, 100, well, our F sub 2 is 150. And take note, our angle is 115 degrees. Where did you get that? That 115 degrees, class, is the angle opposite to our side, which is unknown. Okay? If your unknown is F sub r, so the angle that you will be using is the angle opposite to that. So in this case, since F sub r is opposite here to 115, so we will be using the 115 degrees. But if, for example, your unknown is here, the location of 100 Newton, so the angle that you'll be using is the one here. Can you see my arrow there? So using your calculator, the value of the magnitude of F sub r is 212.552, and take note the unit is newtons. Why newtons? It's because here, if you add this class, this will become Newton squared. This will become Newton squared also, right? So Newton squared plus Newton squared will be equivalent to Newton squared still. This one, Newton times Newton, still Newton squared. So Newton squared minus Newton squared is still Newton squared. You get the square root of a Newton squared is equivalent to Newton. So this will be the value of our magnitude of the resultant force.